Okay, so now recording. My plan is to hopefully let you guys have week 8 off for midterm break. I'm sorry, week 9 off for the midterm. And by that, I mean, since the 16 weeks started back in January. So in our case, we'll do this week, we'll do next week. And then the following week, I'm not going to, hopefully, depending on where we're at, not give you an additional assignment. Or if I do, it'll be a minor one. That way you can get rid of some of that stress maybe, okay? So let's take a look. I'm going to open up Excel here. Get rid of all this that I got. Oh, you guys need to be able to share with me, don't you? Let's see, where's it at? There it is. Share screen, and we'll share the whole thing. There you go. You should be able to see my screen now. Let's get rid of this. It's from yesterday. All right. So again, we've had sequential. That just means one after another, right? We've had decisions, or also called selection. And now we're going to have repetition. Repetition, iteration is the geek term for it, okay? Okay, so the first keyword that we need to learn is the do loop, okay? And do loops are called post-test, okay? That means they will always run at least one time, okay? And what do you mean by test, Doug? Okay, well, loops have 4 parts. We initialize the loop, we test the loop, we do some type of process, and this is the one where people get in trouble. It's called incrementation. Something has to happen in the loop to change the test, the condition of the test, or the loop runs forever. And if your loop runs forever, that's a bad thing. And that's called an infinite loop. And you do not want those. The only way to get out of it for your user is to crash their program. Okay. So you don't want that. But the 4 main parts of a loop. So in our do loop, our order here. So if we had an order here of some people look at this and say, okay, that's 1, 2, 3, and 4, the 4 parts of a loop. Our test, which is normally number 2, becomes number 4. So this becomes initialize, process, increment, and then test. So in this one, our test is done last, okay? In a while loop, it is a pre-test loop. And this loop may never run at all, depending on the condition. And it's done in this order here. We initialize it, then we test. Depending on what the initialization is, we may never, if it's not true, it won't run, and we'll never do the other 2 parts of the loop. And then the third type of loop is a for loop. And for loops are used, and I sometimes call it a counting loop. And that's when we know how many iterations up front. These, so in other words, I want to count from 1 to 100. Well, I know I'm going to run the loop 100 times. If I want to do something if I'm going to have a loan and the loan's going to last for, I know it never changes. It always runs for 3 years, let's say. Then I can make that a counting loop. If something in a do while loop, they can run for like if I do something, if the test never becomes where it stops the program, I can keep doing it over and over and over again until the condition changes to where it stops the loop. Where in a counting loop, we usually know how many times it's going to run up front. Okay. So we got our 3 code structures here. Okay. So we have 3 code structures that you should know. And you know what? It doesn't matter what language you're learning. This all pertains. Doesn't matter if you're doing C++. It doesn't matter if you're doing C#. It doesn't matter if you're doing Visual Basic. Doesn't matter if you're doing Java, et cetera, et cetera, et cetera. This pertains to all of them. Okay. The syntax on how you do it may be different. In other words, the key words here may be a little bit different, but for the most part, they're not. Okay. And all this stuff pertains. It's just the logic behind it. In all the languages, you have these 3 main code structures. Okay. So once you learn this, you should be able to assimilate that into other languages. Like when I learned this stuff, it was back when we had basic A that you used to get with DOS, if you know what that is. And I've never gone back and had to relearn the logic behind my programs, depending on what language I'm looking at. Okay. So it makes it a lot easier to learn new languages once you know the logic behind it. Any questions on this? Okay. All right. So let's look at what we're doing this week. So this one here, okay, the first program is changing decimal into binary. And I'm going to go back to my Excel spreadsheet here. And basically, this is the math behind it, okay? And I explain it again. So let's say I have 247 in base 10 or decimal, our normal counting, what you're used to. So that does say 247, okay? And I want to change that into binary, okay? So binary, we want to know what that is in binary. And that's what your program's going to do, okay? So why do we use binary? Because that's what computers know. Computers without a bunch of finagling don't know what base 10 is. Again, circuits in the computer, how this started was we have what it was called binary digits, okay? And your binary digits, oh, come on, Doug, I'm typing today. Binary digits, we took that together, we took the 2 words and made them bits, okay? And bits are either 0 and 1, or is the circuit open or closed? And that's what a computer does, okay? We just have multi-million billions of these circuits. And if the circuit is open, it's a 1 or it's on. If the circuit is closed, it's a 0. So that's how this all came about. See, base 10 doesn't work real good with that, okay? On and off, that's all we have, and that's all the computer really knows. So it came down that we talked about ASCII before, I think, where we said, okay, if I have 8 of these things, these bits, and this one's on and this one's on, that's the letter A. If this one's on and this one's on, that's the letter B, et cetera, et cetera. So, but now I want to convert my 247 in base 10 mathematically into binary, okay? And how you do that is we take 247 up there, and then we're going to go ahead and divide by 2, okay? So 247 divided by 2 is what, 123? With a remainder of 1. You guys with me on that?
Yeah.
Okay. So then I take 123. Hang on here. What happened there? Let's do this. I wonder if I can just copy that down. No, it's going to put, it's not a 3, it's a 2. Okay. Oops. 2. And I divide 123 by 2, and I get 61. Whoops. 61 with a remainder of 1, right? If my math goes awry, somebody tell me. I was never a math wizard. And then I take 61 and, oh man, I keep typing the wrong thing here. And divide by 2. Gives me 30, right? With a remainder of 1. And then I divide, and I did it again. I take 30 and divide by 2. Why does it keep doing that? Let's see if I can get it right this time. There we go. Divide by 2, and I get 15 with a remainder of 0 this time. And then if I do divide that by 2, I get 7, right? With a remainder of 1. Then if I divide by 2 again, I get 3 with a remainder of 1. And then I'll get it eventually. And 3 divided goes 1 time. With a remainder of 1. And then I divide by 2. Oops, there it goes again. It's a weird key I'm hitting. 2. Gives me 0. 2 can't go into 1. And then, but I'll have a remainder of 1 here. So now, what does that have to do with binary? Well, if you read the remainders from bottom to top, okay, so the binary number here for 247 would be, starting at the bottom, it would be 1111 0 111. So that's the binary equivalent of 247. And because this is 1 1, 1 2, 1 4, no 8s, 116, 132, 164, and 128. Okay. And it works just the same as this is what? 7 1s, 4 10s, and 2 100s. But in binary, we only have 2 digits, 1 and 0. So this is the binary equivalent, and this is how you get it mathematically. Now, so you're going to write a program for me that the student or the user puts in a number in decimal, and your program will convert it into binary. Now, the key is here, you need to concatenate, add your digits on from the front, okay, of your, what your number is. Okay, so the first time through, when it picks up the first number, it puts in a 1. Your remainder would be 1. Then the next time you go, you want it to come out as 1, 1. So you're putting a 1 on the front, not on the back. And then 1, 1, 1. And then 0, 0, 1, 1, 1. Whoops, stop. Okay. So, because you're putting it on with the remainder, you're tacking it on the front, not on the end. Okay, so whatever you have here is you might have something called remainder, and then plus whatever the past remainders were. Okay, so whenever you divide, you're going to put the remainder, the new remainder, on the front, not on the end. If you put it on the end, when you get done, you're going to get, instead of this, you're going to get it backwards. You're going to get 1, 1, 1, 0, 1, 1, 1, 1. A way to test that is if the user puts in the number 8, okay, 8 in binary is equal to 1, 0, 0. Because it's no ones. Oh, I'm sorry. No, it's more than that. It's 1, 0, 0, 0, 1,000. Oh, you can't say 1,000 though. It's one group of 8, no 4s, no 2s, no 1. So if you type in 8 and you get 0, 0, 0, 1, you have it going in backwards. So you should have 1, 0. Same thing here. If I put in a 4, I should get what? What should I get for a 4? Anybody? Nobody?
1, 0, 0.
Yep, 1, 0, 0. Because it's 1, 4, no 2s, no 1s. If they type in a 2, your program should produce a 1, 0. Okay? So that's the first program. Second program's pretty easy. Okay? You're going to flip a coin 1 million times. Okay, so 1 million. That's 3, 4, 5, 6. Yep. 1 million times. And every time you flip, it's either going to be heads or tails. Okay. So you're going to create a random number, right? So you'll have something like this. Flip is equal to, I don't know what you want to call it. My random dot next int. And you're going to put a 2 in there. Okay. So now you're either going to get what? What are the numbers that are going to be generated by this random? Somebody that hasn't answered, or I'll pick on somebody. Madison. If I do this, what numbers am I going to get?
Would it be 0 and 1?
Mm-hmm. Exactly right. So I can make my 0 heads and my 1 tails, or vice versa. So every time it flips for 1 million, I'm going to get one of these 2. And so at the end, I'm going to have maybe, the ideal thing would be I'd have 500,000 heads and 500,000 tails, right? It won't come out. I mean, it might, but chances are it's going to be a little bit skewed one way or the other. What you do not want to do in this program is print out the flips every time. You'll be sitting there a while if it has to print out a million flips. If all you do at the end, all you want is a sum at the end, right? So then here you're going to have an if statement that says if flip equals 0, you plus 1 to the heads, else you plus 1 to the tails, right? And that's the program basically. And then at the end, after the loop is all done, then you print that out. How many heads, how many tails. That program shouldn't take you long at all, okay? I did add a little glitch in there. There's a book called Rosencrantz and Guildenstern Are Dead. And the book is about, if you know Shakespeare's Hamlet, Hamlet's uncle and his mother kill his dad, and they get married. And Hamlet's, a friend of Hamlet's is out on the castle wall one night and sees Hamlet's father's ghost. And he tells Hamlet, and Hamlet goes out there, and his ghost tells him, hey, your mom and your uncle killed me, you know? So anyway, so his uncle and them are thinking, what are we going to do with Hamlet? He's nuts, that kind of thing. And there's two of his buddies. One's called Rosencrantz, the other one's Guildenstern. And the king writes a letter. They're saying, well, maybe Hamlet needs a vacation kind of thing. And so he writes a note to, I think it's somebody in England, the King of England, Queen of England, whatever. And so Rosencrantz and Guildenstern are given this letter because they're going to accompany Hamlet to on this trip, right? What they don't know, Rosencrantz and Guildenstern, is in that note it says, kill Hamlet, but also kill Rosencrantz and Guildenstern. Okay. So the play is about fate. Okay. And in the play that Stoddard wrote, they're flipping, Rosencrantz and Guildenstern are always flipping a coin, and the coin keeps coming up heads. No matter what they do, they throw it over their shoulder, they whatever. And it has to do with like destiny and stuff like that. So if you incorporate anything about Rosencrantz and Guildenstern in your program, you get some extra credit. Or you don't do it and you still get your regular credit. Okay. The one we're going to look at today, and we might not get it done today, is the last one. It's one I made up, and it's an elementary math tutor. Okay. An elementary math tutor. And the elementary math tutor has some rules. Okay. First of all, it's very elementary. The only numbers that we're going to use, that we're going to generate, are the numbers 0 through 10. The next rule is that we're not going to, in subtraction, we don't want any negative numbers. The kids don't know negative numbers yet. The third one is one that's an algebraic thing, in that you can't divide by 0. You can divide into 0, okay? In other words, you can have 0 divided by 2. That's legal in algebra. What you can't have is 2 divided by 0, okay? So we have to check for that. The third thing is that these kids don't know fractions yet. So we're going to make our, when we do division, we need to make sure that every time the answer is a whole number. In other words, let's say we have 10 divided by 3. They don't know what's the answer to that. Is it 3? Is it 3.3? Is it 3.33333? So we're going to fix it so that the only answers they get are the quotient. The answer will be a whole number, and I'll show you how to do that. I think that's what it comes out to. All right. So let's go ahead and get started on that. Since that is the 3 assignments. So we're going to go to NetBeans. The mailman, it must be here. Or the sirens are going off for the first Tuesday. For some reason, they just don't, they hear the mailman. I think that's why they don't like him. They can never see him. All right. So here we are. Like always, oops, that's a craps game there. We don't need that one. All right, so we got a new project coming up. Like always, Ant. And we're just going to call it, how about Kids Math Tutor. All right, so our template comes up. First thing we always do is do our internal. So this is going to be the Acme Kids Math Tutor. And this will be Kids Math Tutor.java. And then today's date, we're already on the 2nd of March, 2021. And author will be you. And the purpose, I program an elementary math tutor where 2 random numbers are either added, subtracted, multiplied, or divided. And then we'll say only numbers between 0 and 10 are generated. No negative numbers. No negative number answers are allowed. No fractional answers are allowed. And of course, division by 0 is not allowed. Oh, and let's put one other thing in here. A student's grade is displayed when exiting the program. All right. So I can see I need a random and the student's going to type an answer in. So I'm going to need to import 2 things. Java utility. And let's see if I can stop it from locking up today. Probably not. Hey, what do you know? That's like the first time this week it hasn't locked up. Okay, so I have those. Clean that up, move my brace down. I do this every time I write a program. Never changes. If nothing else, I'm pretty consistent about this because I like it when it's nicely indented and I can see my braces over my braces. All right. Whoops. That's not good. Oh, I need to put in my little crazy. And believe me, there's a method on why I do this. Again, and I just want you guys to get used to it, because later on, I want you to divide your program up into different modules. And it's just nice for reading for our programmer friendliness. Okay, so the first thing I'm going to do is I'm going to create a char. A char is just a single character, right, in my whole data scheme. And I'm going to call it again. And I'll even initiate it as a capital Y. Notice that's not double quotes there. That's single quotes, okay? All right. Now, is there any time I don't want my program to run? Do I want to have somebody come along, click on my program, and nothing happens? Am I going to have to ask for somebody? Looks like it. Nobody's answering.
I was just thinking,
If you had a program, if you turned on your computer or on your game, say you got your game console, you turn it on, nothing happens. Is that a good thing?
No.
No. So we always want it to run one time at least, right? So if we look back over here, what kind of loop always runs at least one time?
a do loop.
A do loop, right? So we're going to make sure we want a do loop. So right here, I'm actually going to type do. And then I'm going to go ahead and put my braces in. And right now, I really don't have a process. I'll just put in here so you guys know it's there. Okay. Up here, this is, of course, this is my first part. Initialization. So I initialize a variable there. Okay, and then I got my process, which is number 2 here. Okay. And then I need an increment. Okay. So down here, I'm going to go down a couple. I'm going to say system.out.print and to continue press, and we're just going to put an uppercase Y. All others quit. So this is going to be my, okay. So now I need input from the user. So I need a scanner. So I'm going to go back up here and create my scanner. Of the type system in. And then I can come back down here and say, again, is assign the value of my con in next to upper. Okay. And I want the character char at 0. Okay. Oops, I got something screwed up here. Hang on. Okay, next dot 2. Oh, it's uppercase in this one, sorry. There we go. And then char at, and we want the one at the first character. So what that does for us, the user can type in a small letter Y, an uppercase Y, the word yellow, yak, yo-yo, doesn't matter. As long as it starts with the letter Y, the program will keep running. So that's user friendliness. I don't want them to have to type the word yes, for example. Okay. There's more possibility that they make a mistake with something like that than they will just typing the letter Y. And if they do type anything that starts with Y, it'll take it as a yes. So then the reason I had to put the again out here is because of scope. My variable scope needs to be not inside the loop, because if I put it inside the loop, then I have to be able to stop it inside the loop. And I can't do that. I have to go outside. So it's going to say while again is equal to an uppercase Y. And then this is one of the cases where you get a semicolon after a while there. And so this is my number test is 3. No, was that 2? I think I got my process in the wrong spot. My process is the 3 in my little diagram I gave you. And then my increment 2, 3 was 4. So this was 4-point increment. And this one here was my 2, and that's a test. So there's my 4 parts of the loop. Now to test it, I'm going to press this and run the program. And if I did it right, it says to continue, press Y. So I press Y and it keeps going. I type yak, it keeps going. I type yellow, doesn't matter if it's upper or lowercase. I type Y, doesn't matter. I type the letter N or any other letter, the program stops successfully. That's what I want. Okay. So now all my program, until we learn about modules, is going to go in here under process. Okay. It's going to go in here under process. So let's do this. Let's get our, create our random.
Hey, I'm having a small problem of my the line where it's like char again equals y. It's saying that it's incompatible types and the sign value is never used.
Because you put double quotes instead of single quotes.
Yep, that's why.
Let's make it. Oh, let's just make it ran. That's good enough. Whoops. My random. Okay, and then inside the loop, we're going to go ahead and create 2 random numbers. And so they're integers. And we'll call the first one num1. And it'll be my random. And I want, what do I want? 0 through 10. So this can just be 11. Whoops, that has to say next int. So that's going to give me the numbers. And then I need a second number. All right, so there we have our 2 numbers, and we'll test to see that we're getting 2 numbers. Again, no reason to go on if we're not getting what we want. Fix it as we go. Whoa. Blah, 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 random, I ran equals random. What happened there? Symbol method random. Yikes. What did I screw up there? Oh, right here. Forgot my new. Ta-da. All right. There we got 2 and 4. I type a Y, I get 9 and 7. I'm looking for a 0 and a 10. And I can just keep doing it until I see 0 or 10. Oh, come on, Doug. There's the 0. So now I just need a 10 to pop up. Anybody? There we go. I got a 10. So I'm checking to see what numbers I'm actually getting. Okay. Everybody good up to this point?
Yep.
Cool. I guess you're answering for everybody. So, all right. So now I have numbers. Okay. So now we need them to decide, the student, what they want to do. Okay. So we're going to put a menu in, and I'm just going to tell them what they're going to do. So our menu is here, and I'm going to make it look pretty. So I'm going to say special amount print line and make a nice little banner. Why? Because I want them to know what this program is, and I want it to be user friendly. And what did I call this thing again? The Acme. Let's do this. Acme Kids Math Tutor. And I probably can put a couple more spaces. You always have to play with this because it isn't what you see is what you get. So I'm going to put 4 there and 1, 2, 3, 4 or so here before I put in my last 2. And I'm sure it's going to be off for the most part right away. But we can always go back in and we'll add a few spaces to make it centered. I'm going to Control C that to copy it, Control V it to paste it in. And then I'm going to run this just to see where my banner is at. Okay, so I'm not too far off. I think I need to add 1 or 2 spaces. Okay, so we'll go ahead here and I'll just put 2 there for now. And oh, I got my program running still. Okay, so run it. Perfect. It's all lined up. Looks real nice. Type an N to quit the program. If you, here, look what happens. So if I don't quit the program then and I go back to program here, look at, I can't run my program again. So you got 2 ways you can do it. You can do this, click down here to cancel the process, or you can go back to your output and either type your N in, or there's a red dot here. If I press the red dot, it stops the program and my green light goes back on so I can run the program again. All right. So now a menu, let's see here. So we'll do system.out.print. I think that'll be all right. Yeah. So I'm going to say /T. And then I'll do this, A for addition. And then a /N. Hit enter. /T. And then parentheses S for subtraction. Whoa. Then /N for a new line. And then /T for a tab. And for an M for multiply. and then /n, and then /t for division. See, I got multiplication, I got add, subtract. So those aren't the same. I'm going to make this add. So again, if you're going to use addition, subtraction, then you should use multiplication and division. So I'm just going to make these shorter and just make it like that. So now I got add, subtract, multiply, divide, which makes much more sense. And then I'm going to come here, another /n, hit enter. And then I'm not going to put in a /t this time. And I'm just going to type enter your choice, A, S, M, or D, colon. All right. And then we'll have a variable called, let's see, is that right? How do I want to do that? Yeah, that's fine. Let's see if we do int choice will be equal to our con in dot next parenthesis, oops, next dot to upper and char at 0. Okay. All right. And then we're going to go ahead and make sure we're going to get that. So now print line and make sure we're getting our choice here. Always testing to make sure that our program is running up to this point. Okay, so if I type in the letter D, I get 68. If I type in the letter A, it quits the program. I'll run it again. All right, type in S, 8 and 3. I don't know what's generating that. Okay. I must have, oh, here. Where do I have that? Why am I printing that out? That's bizarre. Where am I getting 83? Print ln choice. Oh, that's not a string, Doug, or an int. it's a char. I was wondering what was happening there. That's kind of weird. It's printing out the ASCII number of what I typed in. Okay. I need to stop for a minute here. So you guys get caught up. Okay. Back. And so now we have a nice little menu. Let's look at it again. Looks pretty good. Easy to read. User would look, hey, that's pretty good. I don't like that I don't have a space after the D down here. So I'm going to add that real quick. Put it right here. So I'm not typing right. The user isn't typing right up against the colon there. All right. So now I got my choice and everything working. So I'm going to say switch choice. So now this is nested inside of my loop. Okay. Got that nicely nested. And I'm going to say case A, single quote, A, colon. All right. I'm going to indent this a little farther. I don't like that it's that close. I'm going to go up here, indent that. Much nicer. Okay. So here I'm going to say, I've got my num1, I got my num2. So I'm going to say system.out.printf. And I'm going to say %D plus %D space is equal to space. And then I'm going to go over here and put num1, comma, num2 to fill in those placeholders and that. Okay. And we'll see how what it looks like if we do. Oh, my program's still running from last time. All right, my green light's back on. I click on it. And I select A. And you can see I got 8 plus 0 over there. I need a line feed. Well, yeah, let's go ahead and put a line feed in there. /n. And my program's still running again because I never quit. All right, so let's look at it one last time. And I select A, and I get 4 plus 5. Looks pretty good. Type an N to quit. Okay, so if A is that, then we need, of course, we'll need our, when I do this, I'm going to say that I'm going to declare another variable up here called int computer comp answer, the computer's answer. And we'll just make it 0 for now, or let's make it -1 because it can't generate that. Okay, so we'll just say that. Down here, we then will put in comp answer. Well, the answer to the computer question is what? Well, it's num1 plus num2. All right. And again, we can check it. Whoops. And we run it. Oh, I didn't hit it. There we go. I select A. It says 9 plus 8, and it shows the computer's answer down here. Now, we don't want to show that to the student. Okay, that would be kind of silly, right? So again, that was just for our test purposes. So we're actually going to get rid of that. And then again, this is a switch, so I need to put a break in here because now I'm going to go on to the next one. All right, so that'll be the next one will be case S. And it'll be system.out.printf. And it'll be %sign D, whoops, %sign D minus %sign D is equal to, and then just right out here, we'll say num1 and num2. Now there's a problem here, right? If it generates the numbers 1 and 2, we'd have 1 minus 2, which gives us a negative number. But our rule says you can't have a negative number. So this, we need an if statement before we print this out. And we're going to say if num1 is less than num2, we need to do something. And we are going to switch the two numbers around. Okay, and this is how you do it. We're going to say that int temp is equal to, or is assigned num1. And then num1 will be assigned num2. Then num1, let's see, num1 will be num2. Num2 will be assigned temp. So what I basically did there is swap the numbers around. So think of it. If the numbers originally were 1 and 2, it says, okay, well, 1 is less than 2. Then temp becomes 1. Number 2 goes into num1. So now num1 is 2. And then finally, my temp, which is 1, goes into num2. So now I have 2 minus 1. Okay. So now this will say 2 minus 1. And of course, my answer then, my computer answer, what happened here? Yeah, okay, I'm inside. My computer answer will just be that, num1 minus num2. Okay. Blah, 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 blah. This is, let's go ahead and indent this a little more. Oh, come on. There we go. So that looks nicer there. All lined up. And we can test it. We'll just go ahead and print one more time here. Okay, so if I select S, it says, and it shows my answer there. Do it again. Type S. So that looks good. You'll notice I'm never getting any, I'm not getting where the first number is bigger than the second or smaller than the second number. So again, we don't want to give the user the answer. So get rid of that and just put our break in. Oops. Okay, multiplication is almost exactly like addition. So all I'm going to do here is go up here, Control C that, come back down here, go way over to here, and Control V, paste it in, change this to an S, or I'm sorry, an M, capital M, and then change this. I'm not going to make it a splat or an asterisk. These are little kids, so I'm going to put an X there for multiplication. And then I'm just going to come down here and make that an asterisk. splat, as we call it. And then I'm going to print this one to make sure it works. Excuse me a minute. Comp answer. Okay. And now we can test our multiplication. And if we type an M, 0 times 10 is 0, which is correct. Do it again just to make sure. Type an M. Why am I getting 0 all the time? Hopefully that's just a glitch. Or a dumb, yeah, there we go. 8 times 5 is 40. All right, so that works. And once again, I can get rid of this line here. If you want to leave those in as a test thing, you can always just put 2 slashes in front of it. Okay, so now we got case division. I don't know why it won't indent that as much as I want it. There we go. Get this one too. There, that's beautiful, just beautiful. Okay, so now this is division. So if num1, or no, num2, division, divide into 0, but you can't, is equal to 0, then num2 is equal to 1. It's an easy way to fix that, okay? So that fixes the division by 0. And we can fix this up here too. And this one here eliminates negative numbers. Number answers. Okay. So that fixes division by 0. And now I want, so I don't get fractions, okay? So I'm going to say here, int temp is equal to, or is assigned the value num1 times num2. Okay. Then I'm going to say that num1 will be equal to the computer answer. Okay. And then I'll say that my question this time will be, once again, it's percent D divided by percent, or should we use, is it this one? That's better. Percent D is equal to, okay, blah, blah, blah. Oh, I don't need a slash. I don't want a slash on here. It's crazy. Okay, so that's that, that's that. That works. Well, of course it's used. Let's see. And then this will be like that. Okay. But I got to put in my, so it'll be temp and num2. And then our answer will be, oh, I got to print out, da, 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 da. What's wrong here? Oh, it doesn't like that. If you're going to use that, we need to do ... like that. And that works. And we'll see if division works. So this one here, this one prevents fractional answers. So I run it. If I pick D, ooh, why is that? What did I do wrong? Blah, 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 blah. Temp is da, da, da. How did I get -1 here? Answer is comp answer. If number 1. How can that be a negative number? Temp is that. Comp answer. Why isn't that changed? Oh, no, that's not right in temp. Should be that. I did something goofy here. Temp, da, 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 da. If that's that, that's okay. If no 2 is then int temp, da, da. But why did I get a -1? I got something goofy here I'm not catching. D. -1 again. So that should be 0. So my answer is not getting in what I want. Comp answer. Anybody see it? If I take this, the question is right. The question down here is, why is comp answer coming up to -1 every time? Oh, because I have them backwards. Hello. Nobody noticed that? Comp answer will be equal to num1. Yikes. Now divide. There we go. 7 divided by 7 is 1. Go in here again. Do a D. 2 divided by 1. Okay, why am I getting... And I'll say yes. I want to play again. D again. Let's see if I can get something different. There we go. 30 divided by 6 is 5. That's right. And so it looks like it's running fine. All right, time is up. So there's the basic program. The only thing we need to do is clean it up a little bit, put in our counter so that we can display our their grade, right? So because we're going to want to display their grade, get the count of how many questions they take, how many they answer correctly, and what their percentage is. And we'll do that on Thursday. So get this much of it done, make sure it runs, and it's a pretty nice little program. That's my song and dance, guys and ladies. I'm going to go ahead and stop sharing now and stop recording.